So in this video, we're going to talk about how to select an appropriate model to represent data in DESMOS. So you can look at a table of values and predict whether a linear, quadratic, or exponential function would be best to represent the data. What you can do is you can look at the pattern in the values. So for example, here we have a linear function. Notice that we're adding 2 every time to the y values. So this kind of constant rate of change is a characteristic of a linear function. Here we have a quadratic function. So notice this first time we have a change of -1, then we have a change of +1, then we have a change +3, and then we have +5. So this first rate of change is not constant, but if we look at how much the rate of change is changing, notice that that rate of change is changing by +2 every time. So that is something called the second difference. So that's what makes it a quadratic function. The second difference will be the same every time. What happens in an exponential function? Well, when we go from here, notice that there's a change of times 2. Okay, here we're not adding or subtracting, but if we look at 1.5 divided by 0.75, notice that it's being multiplied by 2. Similarly, when we go from 1.5 to 3, notice that we have a change of times 2. So that's what happens in an exponential function. You are multiplying by the same ratio every time. So that's how we can look at a table and tell whether we have a linear, quadratic, or exponential function. Linear will have a constant rate of change, quadratic will have second differences that are the same, and an exponential function will have a common ratio. So we can also look at the graph. So if you look at how the graphs are when we graph the scatter plots in DESMOS, you can see that a linear will look like a line. Quadratic, you can see here we have like a piece of a parabola, and exponential has this sort of shape. So let's look at this first example and determine whether the appropriate model for the given data is linear, quadratic, or exponential. So I'm going to go ahead and go to DESMOS and I'm going to enter these values into my table. The nice thing about DESMOS is that as you enter your values, it will start to graph your points on the grid. So you can start to get a nice visual of what is going on with this graph. So I'm going to enter all these values. And you can see here, I have a nice linear looking shape, right? If I connect these dots, you can see that I would have a straight line. So what I can do now is I can tell DESMOS to approximate a linear function, and I can figure out whether that is going to be a good representation, right? So I type y1 is approximately mx1 plus b. Notice that it tells me I have a correlation of 0.9996, which is very close to 1. So that means a linear model would be best to fit this data, right? So this is a linear relationship. Now let's try this one. So here we have these new data points. So I'm going to clear this out and I'm going to enter my table. So I have 1, 2, 3, 4, and 5. And then my data points over here. Okay, so now if I look at my function, notice that it's kind of like a line, but if I look a little bit closely, you can see that it's not, it has a little bit of a curve to it. So I don't think it's going to be a linear model. It's going to be probably quadratic or exponential. So how do I figure out if quadratic or exponential is best? Well, remember in quadratic, we have those second differences being the same, right? So if I look at this from 4 to 5, it goes up 1. From 5 to 6.24, I have a change of plus 1.24. 7.7 and 6.24, if I do that, let's see, I have 7.7 minus 6.24, that's 1.46. And then from 7.7 to 9.75, I have a change of 2.05. So if I look at my second differences here, I have a difference of plus 0.24. Here I have, let's see, 1.46 minus 1.24 gives me 0.22. And then I have 2.05 minus 1.46, which gives me 0.59. So my second difference isn't actually always the same because that 0.59 kind of throws it off. Let's look at if the ratios are the same. Okay, so I'm thinking not linear, quadratic. I want to check exponential. So 5 over 4 is 1.25, right? I'm looking for a common ratio here. If I do 6.24 divided by 5, let's see, 6.24 divided by 5 is about 1.25. So this is starting to look pretty good here. Let's see, 7.7 divided by 6.24. That is going to be 1.23. And then I have 9.75 divided by 7.7, and that is going to give me 1.27. Okay, so pretty close to 1.25. So I'm thinking that exponential is probably going to be better. Let's go ahead and try it in Desmos. Let's do y1 is approximately a times b to the x1. And look at that. That function very, very nicely goes through all of these data points. Also, my r value is pretty close to 1, so I think this is pretty good, right? So this is a very good exponential model. Okay, so now let's try this final set of data. I'm going to once again start off by graphing it just to get a visual. So I have 1, 2, 3, 4, 5. And then over here, I have my data points. And 20.2. So you can see I can already, see a curved shape forming here. So it kind of does look like a parabola actually, at least half of one. So I'm thinking quadratic is probably going to be pretty good. But let's just go ahead and double check. If we look at the differences here, so we have 5.2 minus 4.1, so that is going to be 1.1. And then from 7.9 minus 5.2, I get 2.7. And then 12.8 minus 7.9, I get 4.9. And then from 20.2 minus 12.8, I get 7.4. Okay, so now if I look at the differences, the second difference, let's do 2.7 minus 1.1, which is 1.6, 4.9 minus 2.7, which is 2.2, and then 7.4 minus 4.9, we have 2.5. So I know the second differences aren't all exactly the same, but they're pretty close to 2. So I'm thinking quadratic is going to be pretty good. So let's go ahead and try that. So we have y1 is approximately ax1 squared, and then plus bx1 plus c. Okay, so it looks like r is pretty close to 1. And if we look at this graph, notice that it goes very, very nicely through almost all of these points. So my quadratic is going to be a good model here. So by viewing the scatter plot and studying the values in the table, you can determine whether a linear, quadratic, or exponential function will best model a data set using DESMOS.